Hey guys, welcome back to my channel. I hope you are all doing great. If you are new to my channel, don't forget to subscribe and don't forget to tap the bell icon so that you won't miss any updates from my end. Without further ado, let's get into today's problem. Let's try to solve this problem. We will be given one integer array nums and a target, and we need to find the subarray whose sum is greater than or equal to the target, but we need to return the length of a minimum subarray. Minimal length of subarray. So let's try to understand this in much better way. So if we carefully observe, this is our input array, uh, 2, 3, 1, 2, 4, 3. Here, what are the subarrays which satisfy this condition? 2, 3, 1, 2. This is one subarray where the where the subarray sum is greater than or equal to target, and there is something called 3, 1, 2, 4. This also satisfies. Then 1, 2, 4, 3. This also satisfies. Then 1, 2, 4. This also satisfies. Then like that, there is one subarray 2, 4. Sorry, 4, 3. If you look at this all, so here the length is 4, length is 4, length is 4, length is 3, and this is the length has 2. So we need to return this length, okay, which satisfies this condition. Let's try to understand how we can solve this problem. So if we carefully observe the input arrays 2, 3, 1, 2, 4, 3. 2, 3, 1, 2, 4, 3. Okay. So the first and foremost is we will going to apply the sliding window algorithm as usual, and we are going to apply something called prefix sum concept. Okay. Let's try to track it. So initially we will be at this position, okay? And what I do is I take this into a variable called prefix sum. So initially this starts with 0, then 0 plus 2. Okay, I check whether this is greater than or equal to target. No. Then I will come here, I check whether this is greater than or equal to target. No. Then I come at this, I will still check whether it is greater than or equal to no. Then I will come this, yes, at this point of time 2 plus 3 plus 1 plus 2, that is nothing but 8, okay, which is greater than or equal to target, that is nothing but 7. Here our target is 7, by the way. Okay, this satisfied our condition. Then I'm going to maintain a pointer like left, okay, which initially points to the 0th index. Then this is my I. So I'm denoting left with L, and this is I. So as soon as I found this condition, I mean I found a prefix somewhere it is greater than or equal to 7, then what I'm going to do? I'm going to take the its length. How I can take? I minus left plus 1. So what it's going to return? I pointing at this, that is nothing but third index, right? L is 0 plus 1. So what is the output? 4. So there is a subarray of length 4 which satisfied this condition. Okay, this is one output. Okay, 4. And keep this aside. Okay, then I will again check whether one more thing. So when we are trying to take this one, after taking this particular what I can say length, we need to minus this because we can what I can say look for other elements. So sliding window, as you know, we need to slide. Okay, so here the window is between L to I. Okay, or else you can think like I to L. So this is something the window which we are trying to maintain. So as soon as I'm done with this, okay, I need to move my L to one position. Okay, then my L comes here. So now what happens? 3 plus 1 plus 2. Does this satisfied condition like I mean this prefix sum greater than? No. Then what I'm going to do? I'm going to add 4. Then what happens? 3 plus 1 plus 2 plus 4, which is nothing but 4 plus 2, 6 plus 10. Does this satisfy our condition? Yes, because 10 is greater than or equal to 7. Satisfied. Then what I'm going to do? I'm going to what I can say take its length. Okay, so I pointing to this, now L pointing to this. So I is at 0, 1, 2, 3, 4. So 4 minus L is 1 plus 1. What happens? 3 plus 1, again 4. So I got again a subarray of length 4 which is satisfied. But what I'm going to do here is I will check. Okay, so now here the sum is 10. I will check if I remove these, can this also be a possible answer? I can check that. So that's a reason we need to run this in a while loop. Okay, while target greater than 0, then we need to take its length and we need to subtract it, the prefix sum. I will tell. So here the prefix sum is 10, right? So what I do is inside this while loop, I take prefix sum is equals to prefix sum minus nums of left. Try to understand carefully. So what happens? Prefix sum is 10. 10 minus nums of left is what? 3. That is nothing but, 3. That is nothing but 7. Again, I will check whether this condition is satisfying. Yes, 7 greater than or equal 7. Still satisfied. That means what? As soon as I took this, so my L is going to point here only, right? Because I just, what I can say, subtracted its value. Then what happens? Now I is at what? Still at 4. Okay, 4 minus L is at what? 4 minus 0, 1, 2, 2 plus 1. That is nothing but 3. So now I got a subarray whose length is 3 and which satisfies this condition. Okay. Then I can take this simply. Then again, I will try to what I can say, do this operation prefix sum is equals to prefix sum minus nums of left. So what is nums of left this time? 1. So 7 minus 1, that is 6. So I'll check this condition. No, it's not satisfied. Then I will come here, the last element in the array. Then as soon as I come here, what is my sum is going to be? 1 plus 2 plus 4 plus 3. That is nothing but what? 1 plus 2 plus 4, 7 plus 3, 10. Again, you carefully observe. It is greater than or equal to 7. Then I come here. I will take this length first. So I is at here. L is at here. So this is a 4, right? The length from 3 to 1 here. Then I will do what? I will subtract the left one. So 1 will be subtracted. So 10 minus 1, that is nothing but 9. So now L points to this element. The element value 2. Then 9. Is 9 greater than or equal to target? Still possible, right? Then what I'm going to do? I'm subtract 2 from here, but I take this length. That is nothing but 3. I took this length 2, 4, 3 because this is also a possible subarray, right? Then what I'm going to do, I'm going to subtract it from this. Like then L will be subtracted. 2 will be subtracted and L will point to here. And I will check whether this is satisfying the condition. Yes, 4 plus 3 equal to 7, which is greater than or equal to 7. This satisfied. Then what I'm going to do? My I is at what? 0, 1, 2, 3, 4, 5. Okay, I is at 5 minus my L is at 4 plus 1. What is the length? 2. Because 4 plus 3 is 7, which is satisfying. So then finally the answer is 2. Okay, so of course we need to maintain a minimum variable to know every time the minimum one. So you can apply math.min. So this is how the problem statement, this is how we can approach to this problem. So the time complexity is big O of n, the space complexity is big O of 1 because we are not going to take an additional data structure rather than a constant variable. I hope you learned something from this approach. Let's try to understand carefully while we are doing actual coding part. Now here is I am. So as I said, we need a minimum variable, right? So what they're asking is if there is no such subarray, then it's saying we can take the, we can return the 0. So what I'm going to do is min is equals to integer dot max value. Why I'm taking this? Because whenever subarray is satisfied, I need to take it, right? That's the reason I'm taking this as a maximum that you can understand. So int left equal to 0, then int prefix sum starts with 0. Okay, then I'm going to start now iterating. For I equals 0, I less than nums dot length I plus plus. Okay, then every time what I'm going to do here is I'm going to take prefix sum is equals to prefix sum plus nums of I. Okay, first I check while, okay, prefix sum greater than or equal to target. Till this condition satisfies what I said, I need to take the minimum, right? So min is equals to math.min of whatever the current minimum plus I minus left plus 1. okay, so that we can come to know which subarray has the minimum. Okay, then as soon as it's done, as I said, we need to subtract this what I can say nums of left from prefix sum, then this, then once this done, then increment the left pointer. Okay, and we need to do this in while so that we come to know how many are there. And once this is done, okay, you just return. Okay, before that you can check min equal to integer dot max value. If this is the initial one, I mean whatever we, so that means we found no subarrays which is satisfying this. Else we can return this min. So let's see by submitting the code. Yeah, it got ran. Let's submit. Yeah, you see, it got submitted successfully and it took only 2 milliseconds to complete the process. And that's all for this video. I hope you learned something new today. I will meet you in the next lecture. Bye.